Hi guys, welcome to my YouTube channel. So in this class, we are going to discuss mainly on why we are using EV as a general term in the all the case of energy band, not joules. So as in the previous class, I already said that joule is the unit of energy in MKS, but which is too large as a unit when comparing to energy band we get taken. So joule is a unit of energy. Joule is a unit of energy. Energy in MKS system, but which is too large. So in electronic engineering, like in these terms where the semiconductors are coming to picture, in electronics engineering, we use the term of EV. So the physical significance of EV is what means that is very simple for us to understand. So let's take this is on two different energy level, maybe condension band or valence band or anything, whatever it is. So if we think the energy is gaining. So let's take electrons from here is getting some energy or some excitation and going to here. So that we will state as gain. So if another again one electron is from this upper level coming to down, so then there will be release of energy level. So that yesterday we discussed in Bohr's law. So there will be release of energy in some particular wavelength. So for an example, this is 1V or 2V or anything. It's a normal voltage which is same as minus 1 EV or minus 2 EV. The significance between the volt and EV which is same. For an example, if it is a 0 volt, then that will be called as minus 2 EV. That is the relationship, the E and V which is same. So in order to simplify this thing, so let me define another one term. Like 1 EV is the energy gained or released. It's the energy gained or released by electron while climbing or falling. While climbing or falling from a potential difference. So this is the physical significance behind EV and EB. Difference of 1 volt. So 1V which 1 EV which is directly resembling to 1 volt. Okay, so this is one important term you guys have to remember. Okay, so this is how the joule and other things is coming to picture. If 2 EV is there means we can directly make sure that is a 2 volt. So this is energy, this is potential. I hope it works. You are aligned with the explanation I'm giving. So if you have any doubts, please feel free to ping. So 1 EV which is equal to 1.6 into 10 power minus 19 V. So this is the joule. This is the conversion between joule and EV. So if we need the value for 1 joule, then you can easily divide this with the EV. So I hope this gets clarified for you. So now let's get deeper into the semiconductor physics. So this is how one material, the box I mentioned here is the material of Ln, and we are applying the external voltage V, and based on the voltage applied, the electric field will be produced in this direction, and the electrons will move in the opposite direction of applied electric field. So this is the general physics we know. So if you haven't know, please if you know to make a note of it, the electrons will move in the opposite direction of electric field. Okay, so based on this behavior, like based upon the supplied voltage and the electric field and the movement of electrons, they are defining many parameters. The first parameter in semiconductor we are going to define is the drift velocity. So drift velocity, the notation we notice the nu d, like vd or nu d, something they will represent. So the what the drift velocity signifies as is the drift velocity is the average velocity maintained by electron while moving inside a material. So it is the average velocity maintained by electron while moving inside a material. Okay, so this is, so vd, there will be directly proportional to the electric field that get built in. So we know another relationship b, which will be equal to v divided by total length of the material where the electric field is applied. So based on these two terminology, now we have to remove the direct proportionality. So for that, let's take vd, which is equal directly proportional to electric field. So if we remove the direct proportionality, then the constant which come into picture is the mobility. So mu is the mobility. So mobility also one of the parameter of each material that will vary for each material. Based on the temperature it will vary. Everything we are going to cover in this lecture or in this series of lecture. So this is electric field. So VD based upon the N type or P type we will be discussing while we go into doping of the material. So if it's an N type, mu Ne. If it is a P type, then it will be mu Pe. So as I said, this is a varying parameter based on different things. So drift and diffusion, there is two terms. So we have seen the drift now. So drift, there will be mobility is the constant. While discussing the diffusion, I will let you know what's the constant there. So as we know the term mobility, so let's take another one parameter. So this is the second one, mobility as the parameter. So here mu, which will be equal to Vd divided by E. So as you know, this is the materials parameter. So we are making sure from this equation into this. So this will be a constant parameter. In every problem if they give, they will directly mention mu as a 300 or 500, like that way they will give. So mobility is the measure of how easily a charged particle can drift. So this is how easily a charged particle can drift. So based on this, we will be terming the constant name. So the mobility constant, the value is attained in the lab research, where there only they will derive the constant material based on the temperature. So this term will be, it's a constant. So they will directly give in many things. But this VD and E can be varied based upon the electric field. VD can vary based upon the VD, the electric field will vary. But mu will be constant. So next class we will be following upon the diffusion current and collision time and relaxation time. So these are some other parameter. So we will cover in the next lecture, and then we will be starting into the conductivity and the resistivity parameter of the semiconductors. So like, share and subscribe the channel. Thanks. Let's meet in the next lecture.